Welcome there.
Hi, everyone. So who's a maker? Everyone's a maker here. Great. Who's under 18? Do we have any kids under 18 here? Ah, few. Okay. Yeah. Good. So I'm going to tell you a story about the history of computing and why the history of computing can tell us a lot about the future. But I'm also going to tell you a story about education and how kids are really the ones that decide the future, and how we're now living in a digital age. And in this new digital age, every child needs to become a maker, right? Digital skills are nothing, excuse me. Digital skills, thank you. Digital skills aren't just for professionals or maker pros, right? Digital skills are something that now everybody needs. So in China, we use WeChat, right? I use WeChat too. How would you survive without WeChat in China? Never, right? That shows you everything, right? Everyone needs digital skills. And incredible things have happened with technology, right? In the last 10 years alone, the price of technology has come way down. So a little computer like this is a microbit, tiny computer. When I was in the embedded industry 10 years ago, helping people make products, one of these cost $10,000. $10,000 just to be able to develop an embedded wireless device. And now this costs less than $15. And anybody, even in a school, a child, a normal adult, you can make technology that's incredible. Right? Cloud computing. You go to Alibaba Cloud right now, you can get a cloud computer for free. For free. To start doing cloud computing, make your own web service, your own business online. 20 years ago, that was unheard of. Right? It was very expensive to start an internet service. And now artificial intelligence is coming. It's really coming. Soon, you'll be able to go to Alibaba Cloud and get artificial intelligence for free and make your services smart. And that's a real digital revolution, right? We live in the digital age. But that means also that every child that comes out of school needs to live in the digital age. Now, it's also important for me that children become makers, not just consumers. What we see too much of today is children come, they watch television, they read the news that we want them to read, they're just using WeChat as an app, but they're not really creating their own ideas and their own things. And my vision is that we'll have every Chinese child become a maker, create technology. And that's what I'm going to talk about. Now, I've been lucky in my career as a technologist. I've been in the Internet of Things industry for 20 years. I started before there was an Internet of Things. And I got the ability to create embedded technology, to create internet protocols that you use today to run the internet, to make wireless technologies. I was involved with the creation of Bluetooth in the early days, back with Nokia in Finland. So the way we communicate with devices. And that's given me a perspective on technology, how we've created technology, but then, in the end, technologies come back to everyone. And that's because of the maker movement, right? The maker movement's made that possible. Now, my vision is really simple. In the future, every child will be an inventor, a maker, right? And it's our job as makers, old makers, I'm an old maker, as makers, to make that possible. And what does that mean? That means we need education. And that means we need technology and education. And that's what Microbit's about. That's what I'm about. I've taken on a mission last summer. I've left my job as a technology executive at ARM. ARM makes the chips that are on these devices that we all use. And I decided to come and take on the mission to bring technology to children all around the world using technology in school. That's what Microbit's about. So I'll talk about education and makers. Now, the other mission that I'm on is to make this big all around the world. And I'd like to reach 100 million children, parents, and teachers with this type of technology. 100 million. That's my mission. And I want everyone here to help me to achieve that. I think in China alone, we could do 100 million, yeah? No problem. We'll do it. I'm also going to talk about China. Give me a moment to talk about history, and then we'll talk about China, what's happening with Microbit in China. Ah, you know what this is? It's one of my favorite movies. 1984, Back to the Future. So it's interesting. We're talking about history and the future at the same time. Now, what's interesting about this movie is that adults, old people in Hollywood, right? They tried to imagine what the future would be like. And they taught a generation, they inspired a generation, right? With their ideas of the future. That's what we do at Maker Fairs, right? We're creating the future at Maker Fairs and inspiring younger kids. But what's wrong about Back to the Future is that adults didn't realize that in reality, in 10 to 15 years' time, they're not making the future. It's their kids. In 10 to 15 years' time, technology will be completely different than it is today. I'll talk about the future of coding in a moment. It's really interesting. Technology will be different. It won't be the same as today. But what is the same is the skill of making, right? What we need to teach children is the ability to create, the ability to invent, use computational thinking, solve problems, right? Make flowcharts, and then try and try and try and try again until you get it right. Or you just have fun. That's okay as well. Now, how many things in this picture are right? This is a quiz. How many things in this picture actually happen? Do we have hovering cars? Kind of. Do we have nuclear fusion garbage generators on our cars? That's the back. Not yet. Do we have self-lacing Nike shoes? Yes. That happened, but only because of the movie. Yeah. Now, there's another reason that children in school, every school, right, need to learn about digital making, is that in the future, the jobs that those children will have don't exist today. It's estimated that 65% of children starting school today will have jobs in the future that do not exist. We don't understand what those jobs are. And so we also need to turn children into makers for their own good, right? So they can actually participate in jobs in the future. And I have a great example, right? Coding. So we code computers today. How many of you are programmers? You can code. Yeah, I like to code. I'm bad at it these days, but I like it. I see Eric saying the same thing. Yeah, I can kind of code still. Well, I'm going to tell you, in the future, we won't be coding anymore. 10 to 15 years' time, when our children are going into the jobs, we won't be coding. You know what we'll be doing? Because of artificial intelligence? Yeah, we're going to be training, like we train dogs. Good dog. Can you imagine what that would look like? Exactly. Good computer. Yes. Okay, now we're going to do this algorithm. You go like this and you do it. Yeah. Good computer. Here's a reward. Good computer. Now, who can tell me what's funny about this picture? The history of computing. That's a Commodore PET. PET. From 1977, I think, the year I was born. That's a Commodore PET. So we'll teach pets in the future, our computers, how to do things. But the skills of making still exist, right? We have to figure out the problems and the solutions so that people can actually, kids in the future, can actually teach computers how to solve those problems. That takes people. Computers won't figure out the problems and the solutions. We will. Computers will help us to do it over and over again, just like they do today. Now, we all understand making, right? We understand how we take a microcontroller, we take some sensors, some art, and we make something special. But to the education world, this is new, right? I work with teachers now all around the world. I just came from Singapore, right? Working with teachers. And for them, this computing is a new thing. So we have to explain it to them. And using physical computing, so using a real tiny computer to make things in school has a really big effect on kids. It's special. This is what we call physical computing. And it encourages creativity, right? It lets us bring technology into every subject. We can do technology in art. We can do technology in math, geography even, right? Music. We can use technology in every subject at school, starting from grade 1 or even preschool, all the way through high school and university. And it makes teaching, it makes learning a lot more interesting. It also lets kids learn by trial, right? They can try to solve a problem and learn how to get past it. That's special. So I think of it as magic, right? We take digital, we combine it with physical, right? With something that we can see and touch and feel, that makes lights and makes sound and senses our surroundings, make robots, right? We combine those together and it makes magic. And kids love magic. And teachers love kids that are happy in school as well. And that's what this is all about. And for you, it sounds like, oh, I know that, I'm a maker, right? But for education, it's new. And we have to teach them how it works and why it's special. Now, the other thing to understand about physical computing is it's a journey. When we go from being a child and going in education to being a maker pro, that's a journey of technology. There isn't a one-size-fits-all solution. And that's something I want everybody to understand from me as well, that there's many solutions that we can use in physical computing. Now, the microbit, which I'll talk about in a moment, that's made for kids in school, right? That's a very special solution for teachers and children that know nothing about technology. These are kids that have never used necessarily a computer before, never a microcontroller, and teachers that are even scared of computing. They're even worried about using it in school. That's what microbit's for. It's for education, primary and secondary school. That's all it's for. You can use it. It's awesome to make things with it, but that's what we do. But there's much more. When you become a maker, you're in high school, you get into university, or you're just a fun adult, you start using things like Arduino, Raspberry Pi, right? Even microcontrollers that you just buy and make your own PCBs. And that's great. And guess what? The skills are the same. What you learned using a microbit that's really easy, you can use those same skills using an Arduino. But it doesn't stop there, right? You have to think about Maker Pro. That's where I come from, right? I'm Maker Pro. I come from that industry. I've helped make products for 20 years and the technology behind it. And there's a lot of other technology that we have. Professional development boards, right? System-on-a-chip technologies that you'd never normally use as a maker, but when you start making things in hundreds of thousands or millions, you really need to cut costs. And of course, real products. That's a Nest thermostat. And the other one is a Bluetooth-based insulin pen for diabetics. Now, the interesting thing is all of these things share the same technology. I know that those products actually share some of the same chips that are in that microbit. They're running some of the same code even between the two devices. They're using the same standards. So when we're teaching kids and educators, teachers in school to use this technology, actually they're using the technology through their whole life. It just gets different. It gets more powerful. It gets better. So that's something to keep in mind. It's a journey. Physical computing is something you do all your life, and it changes. Now we'll talk about history again. Back in 1981, the BBC in the UK created a computer called the BBC Micro. Now, I was born in America, so my version of this was the Commodore 64. Now, how many of you have used something like this, a Commodore 64, an old computer? A few of us are that old. Okay. So I got my first computer in 1985. And that was a Commodore 64 that I started using. And the magic thing about these computers in these days was that the computer was a blank canvas. It didn't do anything. When you turned on one of these, you got a blank screen, right, with a cursor. That was a basic interface. And you had to program your own game or your own thing that you wanted to use, your own program. And that was magic. That made computing back in the 1980s like making, right? With making, you start with nothing, and you create something. Computing was like that. And what we're doing in the maker movement is we brought that back. We've made computing fun again because you get to make your own thing. And this is the history of where microbit comes from. So microbit's actually the reincarnation of the old computer. 3 years ago, the BBC started looking at what do we need to bring digital skills to young people again. And they came up with all kinds of ideas. Online coding, do we need a community for kids and teachers? And the end result that they came up with was physical computing. What we need for kids to motivate them to learn about technology now is a little physical computer. It should be cheap. It should be tough, right? Drop it, it keeps working. And it should be easy. It should be super easy for teachers and kids who don't know anything about technology. So non-nerdy. We don't use words like SPI buses. We never use the word SPI bus when we're talking about this. And then the BBC did something incredible. We made 1 million of these, and we gave it to every single grade 7 child in the country. It's 1 million devices are out there. Now, when I started last summer with Microbit, I took on the mission to make that happen everywhere in the world. So what we're doing now is we're going to countries all over the world. We're working with their education system, their teachers, the government, and we're trying to find ways to bring this to every child in that country. And we'll talk about China in a moment. It's exciting what we're doing in China. Now, the other interesting thing about this is with 1 million of these in the UK, we could do a lot of great research. So we actually did research on what did this do? What happened when we gave a computer to every kid? And the results are really incredible. 87% of all kids that used this little maker computer said it made computing more interesting. It was fun, right? They liked it. 87%, that's 9 out of every 10 kids actually liked doing this. And I thought makers was only for nerds, right? It's not. Everyone likes this. Even more interestingly, it had a big impact on girls. So we had a 70% increase in the number of girls who were interested in taking more computing, right? Learning more about computers when they were older, just from using the microbit for a short time. 70% increase. And that's incredible, right? Because we want more girls in technology. I have to say, girls make cooler stuff. What do you think, girls? Yeah. Girls make cooler stuff. Us guys are a little boring, right? We always make cars or guns or robots, right? Something that moves fast and blows up. Girls make beautiful things. And we're going to see more girls in making because of this. And now, in the past 12 months alone, we've gone from using microbits in schools only in the UK to over 120 countries where we see activity with microbit. 40 countries where we've officially launched microbit and made it available in schools. And this is actually a live feed from the last 30 days of microbit usage on the web. And it's incredible. We have millions of children using this. In China, in Japan, in Singapore, Australia, all over Europe, Canada, US, even South America, where we've never even been, right? People are using this. And Africa, right? So it's incredible how education, teachers, and kids all over the world, they really love this, right? They want to be makers too, and we're trying to help them. And this is only the beginning of the journey, right? We have many more millions of kids to go work with this type of technology. Now, what I'm really happy to be doing here in China is announcing that now microbit's officially coming to China. We're launching in China, and not just China, Greater China. Every country that speaks Chinese, we're launching microbit in. Today, actually yesterday, we decided to do this. And we've done it with a great group of partners, right? We don't do this alone. We're just a small group of people who care about education. We work with partners. So we're working with a maker committee of teachers in China, teachers who work together, the STEM teacher committee. We're working with Chahua makers who organizes Maker Faire, Seed Studio, DF Robot. We're working with education organizations who are actually going and working in schools, like in Chongqing, where we have a pilot that I'll talk about in a moment. We're working with resellers, everyone. And everyone's welcome to work with microbit, right? We love community. You should make stuff for microbit. You should go volunteer in your school and help your teacher with microbit. You should use it with your kids, right? And teach them about computing. That's the kind of thing that we like. And our goal in China and all through the Chinese-speaking world is to deploy microbit in every single province, in schools, not just with makers, in schools, right? That's our goal. It'll take us years. We're going to do a lot of work to make that happen, but it's already started. It's really exciting. Now, already today, before we've even launched microbit officially, the Chinese-speaking world is the #3 biggest user of microbit in the whole world. #3, just after the UK and the US. And that's incredible, right? And it's grassroots. It's makers being interested to do this. It's making it happen. We already have simplified Chinese language support on everything that we do. We have a Chinese website, microbit.cn, that we make available to everyone. And Monday, we plan on releasing traditional Chinese language support as well. So Cantonese, Hong Kong can get involved too. And finally, something really important to China is that we're working on offline technology. So today, microbit's an online service that's free. It works on the web. We're also going to be making offline packages that work on a USB stick. You plug it in, everything works. Lessons, project ideas, editors, Python, JavaScript, everything works offline. It's really important for the Chinese countryside in particular to make that work. We have big deployments in China too, so we're being used in schools all over the country. Lots of, I'd call them pilots, but a Chinese school can be several thousand kids, so they're actually quite big pilots. And I want to talk about Chongqing. So in Chongqing, we have the, and I'll pronounce it right, Renmen Chiachua Chongqing School. It's a primary school that we're working in with microbit. And the pictures I've seen coming from there and the response from that has been just incredible. We're also working in Hong Kong. I've spent some time in Hong Kong, and Hong Kong's really interesting. The teachers in Hong Kong have taken microbit. They've asked for it. They're really excited about using technology. And already in a short period, 4 or 5 months, we're in over 50% of all schools in Hong Kong. Over 50% of schools in Hong Kong are using microbit. It's absolutely incredible. We have some great partners there. And one of the things I wanted to point out, this picture to the right, those 2 boys, I think they were about 12, came to me in one of the workshops we did in Hong Kong. And what I love about this maker movement, it's also an entrepreneur movement. I'm a startup entrepreneur. I love entrepreneurs, right? They take something, they make it real. Those 2 boys came to me and said that, hi, we're both the CEO of our company. We're doing microbit training, and we're going to do this and that. We're both the CEO. So that's me going, wow, you're both the CEO. That's great. But don't you guys realize that actually the CTO has much more fun? Chief Technology Officer. You guys should be fighting for that. That's this discussion in Hong Kong. But it also shows how making is also making kids interested in being entrepreneurs, which is great. Really simple summary, right? Digital skills and creativity are for everyone, right? We want all kids to have a chance to be makers. Even if they end up becoming teachers or doctors in the future, right? Or farmers. We want them to understand technology and have fun with it. That's our mission. And teachers matter, right? We shouldn't underestimate the importance of teachers, right? And that can be any kind of teacher. It could be you as a parent working with your kids. It could be you as a coding club, a makerspace, right? A makerspace where kids come. You can mentor those kids. And just supporting their interest in technology can change their life, right? That kid might become the next Eric Pan in China. Just because you encourage them a little bit, right? To go and do something. Makes a big difference. So support your teachers. And finally, physical computing rocks, right? What we use as makers, what we pioneered, it's awesome. Teachers love it. Kids love it in schools, right? And they're going to become makers in the future too, thanks to what we can do with this. And I'll leave you with that. Thank you, everyone.
Thanks, Zach. So, 这是一个非常非常好的分享。在我们做这几年关于这些创客教育的，在这几年关于创客教育的过程中，其实我们觉得，其实教小孩科技，在他们自己的眼中，在小孩的眼中，更像是他们在学习魔法。科技变成了这个时代的魔法，他们用科技去生成新的东西，去改变新的东西，去以新的一个维度去感知这个世界。所以我们非常感谢 Microbit 这样的一个宏伟的愿望，从英国开始一路走到中国，想要把更多的中国的小孩变成创客。然后我也非常荣幸能够邀请到这么多老师跟我们一起去见证这个时刻，去开始这样的努力。不知道大家有没有问题想要问 Zach？ OK。
Thank you, Zach, and that was an inspiring speech. About the future of coding, I was about to arrange a course for my daughter to learn Scratch, like the coding, and then you told me in 10 years from now, coding would be the same anymore. The computers will be doing coding, so should we be learning coding anymore? Thank you.
It's a really good question. So the question is, should we be learning coding, even though in the future we might not code computers? And the answer is absolutely. And the reason is that coding, Scratch, or coding, we do blocks on Microbit, or Python, right? Or C++ and C. Those are skills, not just languages. So we learn about computing as a computational thinking. We learn about problem solving, right? Flowcharts. Organizing our thoughts, right? Those are all skills that are important in the future for engineers and technologists. Even if you might not be coding, you might be training. You still need the skills. So absolutely, we should be using Scratch and Scratch Junior in schools as well, and with your kids, and then you should have them coding on physical devices. And when they go to university, right, they'll learn about the next thing. But they'll have the confidence to be makers, right? They'll have the confidence to go do it. They won't be scared of technology. That's the important thing.
So it would be just skill trainings. It won't be a future for as a profession anymore.
Well, I simplified things, right? In reality, you're always going to have some people who are very deep in technology, right? Like when you use your computer, there's a BIOS underneath that the operating system runs on. Somebody develops that BIOS still today. Some of it's written in assembler language even, which is not a common skill. And that will be the future, right? We'll have people who are doing low-level coding on physical devices that then somebody trains on top of it. Somebody still has to program the device and program the AI. You'll have AI developers, right? Infrastructure developers, you name it. So it will still exist, but it won't be the only way to go and use the technology. More and more, training will become the kind of way of the future of using the technology.